So for this presentation, we're going to be talking about the relationship between exercise and the brain development of a fetus. The article is written by Elise Labonde Lemonnier, Daniel Currier, and Dave Ellenberg, and the article is found in the Journal of Clinical and Experimental Neuropsychology. So when talking about relevance, I want to point out that we all at one point have been a fetus. We were all in our mother's womb, and some of us at some point might consider having children. So it's very important to know what exactly goes on when we're talking about human development and fetuses. So this study provides further insight as to why we should study that mother and fetus relationship. We know about the negative effects like smoking and consuming alcohol during pregnancy, but not so much is known about the positive effects that can come about this relationship. Talking about the background that the article provides concerning rat pups and the relationship between mothers and fetuses in the rat population, they showed that from the previous literature that rats born to active mothers have enhanced hippocampal neurogenesis and higher levels of brain-derived neurotrophic factor in the frontal cortex. So the hippocampus is your memory station of the brain. It's in charge of memory, and brain-derived neurotrophic factor is associated with neuronal survival and growth, essential for learning and memory. So as a result of knowing these two things about the brain, we can see that the rat pups that were born to active mothers had better learning curves and performed better on spatial memory avoidance tasks. In the previous slide, we talked about background concerning the rat population. In this slide, though, I want to talk about background as it pertains to humans. So just in the one article that we're discussing here in this PowerPoint presentation, they listed that humans who exercise have faster responses on decision-making tasks, have a better executive function, and have an increased hippocampus volume. So now these are just the set of listed benefits that one study has reported, but there's actually a lot more proof. Just in this image below, I've included 5 screenshots per se of a couple of different journals, Human Kinetics, the Harvard Review, etc., all about how exercise affects the body in many positive ways. So it's definitely something that we should be paying attention to and should be studying further to see what other aspects of our lives does exercise affect, such as the relationship between mother and fetus. Going off a little bit away from the article and just talking about the overall significance of why articles like these are important, we have to look at what is currently going on with the country. There is a raging obesity pandemic. It is now more important than ever to take care of ourselves and our bodies. Children who are born to obese and overweight parents are actually more likely to be overweight and develop a horrific amount of health problems as a result: heart disease, type 2 diabetes, the works. So the real, I guess you could say, solution is to focus on prevention. Stopping the problem early. And as this article goes on to imply, we can start as early as when the sperm and egg come together. We win when it's prevention. It's not rocket science, it's exercise science. Humans are a species that were not meant to be sitting behind a desk for hours on end. We're meant to be active for a certain amount of time each day. And the more we own into that, the better we start feeling. Going now into the methods of specifically the participants of this study, there was a total of 29 women recruited in the first trimester. They were recruited by their obstetricians and gynecologists from the Montreal area, as well as advertisements on Facebook, articles in the university paper, and specialized blogs. After accounting for dropouts and people who were disqualified from the study, there were a total of 18 participants, 10 who were designated into the active group, and 8 who were designated to the sedentary group. The participants also completed a socio-demographic questionnaire and a monthly Beck's anxiety inventory. As you can see in Table 1, participant characteristics at entry in study, you can see that there isn't a lot of deviation when it comes to age, years, pregnancy exercise habits, average anxiety, or even family income. And this will actually be very important when discussing the results of the study. So moving on to the actual intervention that was conducted, the women had to complete at least 3 exercise sessions per week, and at least 20 minutes had to be at 55% of their max heart rate. They did keep a daily log, and they also attended one supervised exercise session a month on a stationary bicycle to verify the intensity and whatnot. Also, a kinesiologist kept track of the exercise and contacted participants if they were doing too little or too much. So activities performed was converted in METs, metabolic equivalent of task, using a standard index table. And then the MET was then used to calculate the volume of the exercise. So intensity, METs, times the duration in minutes equals the volume of exercise. As seen in Table 3, details of exercise performed, we can see the frequency, volume, and steps per day for second and third trimester for the active group and the sedentary group. You can see that the active group worked out for a mean value of approximately 3 days per week, both in the second and third trimester, while the non-active group worked out for less than 1 day a week in the second trimester, and even less so in the third trimester. This chart just basically breaks down everything from frequency, volume, to steps per day. Frequency being calculated by number of active days per week, volume being calculated by the formula shown on the previous slide, and steps per day as steps per day. Going on with the methods, we're going to talk about how they actually measured brain activity in the newborns or neonates. So they were all measured once they were 8 to 15 days old. They were given an EEG to measure their brain waves, and they were also given like an auditory stimulus measure to measure sound response and discrimination of different sounds. Now, these are the results which can be very easily broken down into these 2 figures. First, I want to talk about the amplitude graphs. So, as the authors of the study point out, the lower the amplitude, the more mature the brain is. And this finding is consistent with the rat pups study. However, their sample size was not large enough to find any significant difference. But as you can see, like from just these couple of graphs, you can tell very well that if maybe the sample size had been increased, there could be enough to call it statistically significant. This finding about the lower amplitudes with the more mature brain is consistent with the rat pup study mentioned in the background section. Now, taking a look at the bottom figure B, looking at the active and the sedentary groups, you can see that the non-active group is brighter. So actually, it looks counterintuitive of what you would think. You'd think brighter means better, but actually in this case, it's actually the reverse. See, the synapses in the active brain are reduced, but they're reduced in a way which make the neural configurations more efficient and more localized. So you have better, more efficient responses in the brain going on. So less bright on the machine, brighter in the future, I guess you would say. So the authors did offer up a couple of explanations that I'll go into now. They did talk about blood volume of active women being greater than the blood volume of the non-active women. So basically what this means is that since there is more blood volume, there is more oxygen flowing through the blood of the women, and eventually that blood does reach the baby. So a greater oxygen and nutrient supply in the blood could increase brain maturation. They also talked about brain-derived neurotrophic factor, BDNF, being able to pass through the placental barrier. Thus, an increased BDNF in the mom directly goes to the baby. As shown previously, exercise does increase the BDNF in humans. So it's safe to say that since BDNF can pass through the placental barrier, the baby could receive some of the effects of exercise directly through the brain-derived neurotrophic factor. This is consistent with the animal studies showing higher hippocampal concentrations of BDNF for the babies of active moms. For the conclusions, I actually included what the actual conclusion section of the article was like. So it reads, our findings reveal that maternal exercise during pregnancy had a significant impact on the brain of newborns, more specifically on the SPMMR response, a neuropsychological index of sound discrimination and auditory memory. Given that both of these abilities are important components of language acquisition, this could be the precursor to the long-term benefit of exercising during pregnancy on language development for the child that was observed in other studies. So now, basically, just to break that down, they do talk about the auditory discrimination stimulus as being associated with the hippocampus as a way to recall different auditory sounds is related to memory, and that, of course, your memory is related to your language development and language acquisition. So this isn't by no means saying that exercising during pregnancy is going to lead to the fetus being bilingual eventually. No, what it means is just it's better for the baby in terms of brain development because of your brain maturation, because of the increased BDNF in the baby, and because of more efficient synaptic responses. So all of these are things that babies do acquire like later on in life, but the earlier they start, obviously the better that it is for the newborn. So just looking at it in a big picture kind of view, we tell mothers not to smoke while pregnant. Well, not to smoke, period, but not to smoke while pregnant because it has devastating effects on the baby. We could actually be telling mothers to consider exercise during pregnancy to be able to help their baby's brains mature a little bit faster. And mothers would almost do anything for their child. And it's really something that we should consider when talking about health and when talking about mothers and their relationships with their unborn child. It's how to really take care of them. Yes, you have prenatal care. Yes, you have regular doctor's visits. But now adding in this component could really change the game in producing just healthier babies all around. And, healthy babies grow up hopefully to be healthy humans. And that's all we can hope for. This study isn't the only of its kind to look at the relationship between exercising mothers and their newborn children. There was another study conducted in 1999, but it had a lot of issues and limitations that this study, did address and did talk about. That being said, this study was not perfect by any standards. It did have a small sample size, which did lead to some discrepancies, especially when you're trying to calculate statistical significance. And also, the sedentary women, so the non-active group, they were still allowed to work out, but they couldn't work out for over a certain amount because they weren't being monitored. So when taking this into consideration, if you really would like to see the effects, then you would have a non-active group being non-active completely. But that's also, you have to draw a line about your ethics. Can you really say to a person, no, stop working out, because we're trying to see like the effects of when you do work out. So the other limitation was daily log reporting. A lot of participants could have misled the researchers into how much they were working out, how many steps they were taking, or whatnot. However, I believe this is counteracted because of the monitoring by the kinesiologist. As I did mention earlier, the kinesiologist did once a month supervised sessions, and the kinesiologist did monitor the participants to make sure if they were under their requirement, they worked out a little bit more, and if they were over their requirement, they were obviously excluded, or they were told to stop working out. So the sample, even though it was small in nature, it was mostly evenly distributed. You had 10 active and 8 inactive. So it wasn't like a huge 20 to 1 person being non-active. And they were also randomized to be non-active or active. So being that it just wasn't 10 women who were active already and who were pregnant and then decided, okay, I want to be in the study, so see how that would work. It didn't really work that way. It was just these 18 women, and they were just randomly split up into 2 groups, active or non-active. And so they ended up with 10 in the active group and 8 in the non-active group. And I think that randomization really just, it doesn't take away from the fact that it was a small sample size, but it does evenly distribute it in a way that it makes the findings acceptable. Future directions for this study obviously include more replication. The more these scenarios are recreated and the more these results are reproduced, the more validity it gives it. Obviously, what would be beneficial would be to conduct more advanced, but yet still safe tests on the neonates. So, for example, taking full image MRIs, seeing exactly what is going on in the brain, that would really allow us to understand how exactly the exercise is affecting brain development, instead of just waiting until after they're born to take a couple of non-invasive and non-dangerous exams. So in this slide, I want to talk about the references, specifically the source that I mentioned on the obesity pandemic slide when talking about the relevance and significance of this project. I find this article to be interesting and unique because it really provides a lot of insight into an area that not much is known about. Sure, we know a lot about human development, but we really don't know a lot about the human brain per se, and especially we don't know a lot about the human developing brain. We know as we go through, infancy, childhood, adolescence, adulthood, and then eventually later adulthood, we have a general idea of sort of what's happening inside the brain, but we don't really have a key understanding, which is why things such as Alzheimer's and dementia happen in the elderly population. I think understanding how our brain works from the very moment it's created is paramount to understanding how we can preserve it later on in life, for all of life. And this article is also unique to me because of its connection between exercise and neuropsychology. Exercise has been proven to be beneficial in many ways, as I've said before, and I really find it to be extremely interesting and beneficial to society, especially when we look at the state of affairs of what our society is going through right now. like I mentioned before with the obesity pandemic. We're just not as healthy as we should be, especially given with all the advancements that we've made. Our life expectancy has actually tapered off for the first time since the dawn of modern technology and medicines. And I think that says a lot about what we're doing and how we're living. And if we don't change that now, our future is really in jeopardy as to how it will become. WALL-E was a great movie, but what happened to the humans in WALL-E should not ever be recreated in real life. Thank you.